Hello, land and water managers. Now, if you're interested in using LiDAR, light detecting and ranging to understand forests and particularly how they interact with waterways, I've got a couple of minutes that might be interesting for you. If you look at LiDAR, so often we have two different ground returns. So that's just a laser getting bounced from the surface back to a plane or a drone or something, or a helicopter, something of those descriptions. And it gives you two types of reading. One is a digital terrain model. Now that's just the total terrain from the surface with no vegetation, and then a digital surface model, or sometimes called a digital elevation model, where it gives you the whole surface, including the trees as well, so including the terrain. So all we can do is we just take those 2 points, we subtract them, and then we get from the ground to the tree to get a canopy height. Super simple and used everywhere. So often this is applied to get forest extent maps, so areas covered by vegetation. So you ask for a certain threshold, tree height map. So no, this is a interpine image here using a really good LiDAR to sort of understand forest composition. And, forest inventory mapping. And in our case here today, we're just talking about others, which is waterway management as well, particularly riparian management, vegetation around waterways. So if we just think about how we might use that as land and water managers, as an example where we've used it to map waterways versus vegetation or canopy heights. Now this map, and we'll go into a little bit more detail when we've mapped an entire region, this is sort of zoomed in a little bit to a smaller sub-catchment, demonstrates where you've got different height classes against the waterways that are mapped in there. So the different colors represent different heights. So purple being really high, sort of 15 meters above, blue being 0, and a whole bunch of colors sort of in between. Now, if we look at this sort of waterway understanding, we can use it in lots of different applications. So we can understand where we've got forest around our waterways. Obviously, they're very good for shading, cooling, biodiversity, stabilizing riverbanks. And we can understand we've got headwaters in forests as well for flood mitigation and other really useful tools. The second part is looking again a little bit more detail around vegetation height classes. And this image on the right hand side there just shows different colors for different vegetation types. So we've just asked the model to tell it, color it in where we've got different vegetation types. So this enables us in our case to identify different types of weeds, because not many native or beneficial plants in this catchment that we're looking at. But also if you've got a newly planted riparian margin, or you've got native revegetation occurring, we can look at riparian forest succession. Do you have just small underlying kind of sedgy type plants, or have you got more mature canopy trees stitching your riparian zones together and providing shading? So really interesting for a management point of view. So how we are using it is these two main ways. Identifying riparian areas, waterway areas that are absent of vegetation. And we're doing that for a couple of reasons. They're really susceptible to weeds. In this area, we've got water celery, cowcress, whatever you want to call it, really invading this entire catchment. And waterways are way more susceptible to this invasion if they don't have canopy trees and there's no shading on the streams, right? So we can really look at sort of control regimes, planting regimes, and it's all kind of measurable and costable as well, because it's done through GIS analysis. And yeah, you can get basically a big spreadsheet of what your opportunities are or your challenges might be in a catchment as well. So that's the top one. Looking at the bottom image there, this is what we're interested in. This entire sub-catchment that we're looking at is full of invasive willow species. So we're trying to work out how to get rid of them in the catchment. And as you can see from the screenshot of the upper catchment, we've got a bunch of willows probably coming in. They're not at full canopy height, they're much lower, but a really good place to start for control. They're just sort of starting to invade this area. They're at the top of the catchment, so they won't be spreading too much further up. It's a really good place to start. So we can focus on that. It's much cheaper, of course, as well. So it enables us to prioritize, be very strategic in our approach, and provide the best return on investment for our money, which is limited. So anyway, I hope that very short presentation was useful. I really encourage you to use LiDAR in catchment management. This is one application that we've used it for, and I hope it was useful. Take care. Bye.